Therefore, the first part will be 0, then a into dd theta cos theta minus a sin theta. Finding derivative with respect to x. Say some standard form, as well as in case of implicit function we have found dy dx. But we are now going to discuss the derivative of a function with respect to another function. Derivative of parametric function. First, let me discuss what is parametric function. It is found that x and y are not directly related in some cases. They are related via a third variable. That third variable is called parameter. In that case, to find derivative, we have to use different technique. I discuss that first. X in terms of t, y in terms of t. That means x, y are not directly related. They are related via a third variable that is expressed here as t. Now, what to do to find the derivative? We have to apply here the idea of chain rule. What is that? Y is equal to phi t. Therefore, dy dt, that is equal to ddt of phi t. Sorry. ddt of phi t I take that as phi dash t. Now, and for x, we can find easily dx dt, that is f dash t. Now, dy dt, that can be written as dy dx into dx dt. dy dt can be written as chain rule, dy dx into dx dt. From that, dy dx is equal to dy dt divided by dx dt. Therefore, finally we shall use this relation. dy dx is equal to fraction, numerator is dy dt, denominator is dx dt. We shall apply this concept. Now, let us take example. X is equal to 80 square, y is equal to 280. First, you note that x, y are not directly related. x is given in terms of t, y is also given as in terms of t. Then we have to use this concept. For that we follow these steps. I do like this. On the left side I find dx dt, that is equal to ddt of at square. Now a is constant, therefore a into derivative of t square, that is 2t. Therefore finally dx dt equal to 2at. Now on the right side I find dy ddt of 2at. 2a is constant, therefore 2a into ddt of t. Therefore dy dt is equal to 2a. dx dt found, 2at, dy dt found. Therefore dy dx learner, I suggest first you write down this original form. dy dx equal to numerator dy dt, denominator dx dt, then put value. Therefore dy dx is equal to 1 by t. Finally we get dy dx equal to 1 by t. Sometimes it is required to find derivative in terms of say y. From this we find t equal to y by 2a. Hence, if you were to express dy dx in terms of say y, then I put the value to express that in terms of y, that will be finally 2a by 1. This form is in terms of t and this form is in terms of y. Also a is there, a is constant. Next example, x equal to a within brackets theta plus sine theta, y is equal to a within brackets 1 plus cos theta. We have to find dy dx at theta equal to find dy dx at the point or at theta equal to pi by 2. When first we shall find dy dx with the help of the idea of parametric form. Therefore dx d theta is equal to dd theta of a theta, that means a into derivative of theta, that is 1 plus constant a into dd theta of sine theta, a plus a cos theta. Y is equal to a plus a cos theta. Therefore, dy d theta is equal to derivative of a with respect to theta. With respect to theta, a is constant. Therefore, the first part will be 0, then a into dd theta cos theta minus a sin theta. Here we can take a common factor. Therefore, dy dx is equal to dy d theta divided by dx d theta. We put value dy d theta is equal to minus a sin theta and dx d theta, that is equal to a cancelled. Therefore, finally, now there is 1 plus cos theta. We use that identity 2 cos square theta by 2, and for sin theta 2 sin theta by 2 cos theta by 2. Therefore, 1 cos theta by 2 will be cancelled. These 2 will be cancelled. Therefore, finally, dy dx is equal to minus sin theta by tan theta by 2. Now we have to find the derivative when theta equal to pi by 2. Just at this step, we have to put the value of theta. And that is expressed by, therefore, dy dx at theta equal to pi by 2 is equal to minus tan theta by 2 when theta equal to pi by 2. Therefore, dy dx at theta equal to pi by 2, or when theta equal to pi by 2 is equal to tan theta by 2 is there. Therefore, theta is equal to pi by 2. Therefore, theta by 2 will be equal to pi by 4. That means minus tan pi by 4, that is equal to minus 1. Therefore, finally, dy dx at theta equal to pi by 2 is equal to minus 1. Answer. Now, I must mention one thing. If you are to find the derivative at certain point, first of all, you are to find the derivative general form like this, then you are to put this value. That means, in this case, two parts are there. First part is this, then the second part. Now, if you do wrongly this part, then marks will be awarded for this part. Therefore, be careful. Another sum: x equal to a into cos t cube, y equal to a into sin t cube. We have to find dy dx. The steps will be x equal to this, therefore dx dt is equal to ddt of a cos t cube. A constant, therefore a into derivative of this cos of t cube. That means function of function form. We have to consider t cube a new variable, say u, That means you have to first find ddu of cos u into du dt. First of all, cos function is there, therefore finally it will be minus cos of t cube, derivative will be sine minus sine u, minus has been written here, sine t cube into ddt of t cube. Follow that step. Used chain rule. Therefore, derivative of t cube is 3t square minus a, I write 3 here, t square into sine t cube. This is dx dt. Now, we have to find dy dt. dy dt is equal to ddt of a sine t cube. A is constant outside, then ddt of sine t cube, function of function form, ddt of sine say u, that means cos u into ddt of t cube. Therefore, finally 3a t square, derivative of t cube with respect to t is 3t square into cos t cube. That is the value of dy dt. Thus, we have got dy dt and dx dt. Therefore, dy dx is equal to dy dt divided by dx dt. Put the values 3a square cos of t cube by minus 3a square sine t cube. Now, these will be cancelled. Therefore, dy dx is equal to minus cot t cube. We can use the brackets also. Cos theta by sin theta form, that means cot theta. Therefore, finally, dy dx equal to this one. Thus, we have explained the method of finding derivative of parametric function. Next, we have another function or another form where we have to find the derivative. I call that rule 6. We find the derivative of a function with respect to another function. Actually, till now we have determined dy dx. That means finding derivative with respect to x. Say some standard form, as well as in case of implicit function we have found dy dx. But we are now going to discuss the derivative of a function with respect to another function. That means in the earlier cases we have considered x as independent variable and y is dependent variable. But in this case, both dependent variable and independent variables are two functions of x. This can also be treated as parametric form. Just we are discussing here separately to find the derivative of a function with respect to another function. It can be treated not differently than parametric form. Just I have discussed here separately to get the idea better. I discuss this by taking example. To find the derivative of tan x with respect to log x, where 0 less than x less than pi by 2. Not derivative of y with respect to x. Both are functions of x. The method of obtaining derivative is same as that in case of parametric form. Solution. First we take these two as new variables. Say let y equal to tan x and z equal to log x. Hence, we have to find dy dz. Now you see, we shall follow the same idea in case of parametric form. Here we note y in terms of x, z in terms of x, and y, z are related via the variable x. That means similar to parametric form. I do on the left. Now y equal to tan x. Therefore, we can find easily dy dx, that is equal to 6 square x, and z equal to log x. One thing already it is mentioned in case of calculus, if the base is not mentioned, log x means base is e, natural logarithm. Therefore, dz dx equal to derivative of log x, that is 1 by x. Therefore, dy dz is equal to dy dx by dz dx. The form used in parametric form. Now we put the value and simplify. Dy dx 6 square x and dz dx equal to 1 by x. Therefore, dy dz is equal to x 6 square x. That is the answer. Thus, I have discussed all the methods of finding derivative of any type of standard function as well as any form of function, function of function, parametric form, implicit form, also logarithmic differentiation. We have thus discussed, or if you practice, then you will be very much strong in finding derivative of any type of function.